All right, so hopefully I got this working. Welcome everyone to week number 3, and this is going to be so from the syllabus. I'm kind of adjusting the syllabus just a little bit because when I started chapter 3, it was kind of really tech heavy for a lot of people that don't have a lot of experience with electronics or just learning about it. So we had chapter 3 first half last week, and then we had chapter 4 first half. So I figured if I broke it up into halves, it would be a little bit more digestible. So we're going to do the second half of chapter 3 and the second half of chapter 4 today. So second half of chapter 3 is electricity, components, and circuits. And then chapter 4 is propagation, antennas, and line feeds. Now, another thing I wanted to mention is that the test questions, there's 35 out of total that you have to take, that they'll ask you. And on the last half of the syllabus, on the last page, or on the second page, I've got the breakdown of the elements, and they start with T1 through 10. They're test elements they're like groups of subject matter. So T1 is FCC rules, and there's 6 questions from that out of the 35. T2 is operating procedures, and there's 3 questions, and so on. So the electrical principles is T5, T6, electrical and electrical components. So that's 8 questions. So if this part is kind of difficult for you, just, you could miss 6 or so and still pass. Don't stress out too much. So just keep that in mind. All right, so we're going to go with chapter 3. I think it was about section 9, 3-9 is kind of where I left off, which was components and units. And I'm going to do a little bit of a review, and then we'll go into the next part. So the basic types of electrical components that are important to remember are for resistor. There is what's called a schematic, which is a way of describing an electrical circuit and diagramming it out, and that's a test question. But the way they do it is they put like little symbols for each of the electrical components, and they'll put a letter and then a number. So like C is capacitor, and it might be C1, C2, C3, that's capacitor number 1, number 2, number 3. So if you see a C, that's capacitor. R is resistor. I is inductor. And there's various symbols, and there's a section in the book on schematics with the symbols, and it's on 3-15. So that's there for you to study and kind of look over. But in fact, I'm just going to show you a couple of them. So if you go to 3-15, the upper left-hand corner has resistors. So those are the symbols for resistors. It's like a straight line with little wavy zigzag pattern. A potentiometer is like varying the resistance. So if you think of the arrow as how much resistance it points in the middle of it or the left or the side, it increases or decreases resistance. And that's how a volume control works, a mechanical one. So there's resistors. C is capacitors, and it's kind of like this two little, one's a straight line, one's kind of a curved line like a C shape. So there's 2 different types of ways you can store electricity. One is and you can store it in an electric field, or you can store it in a magnetic field. So an electric field is how capacitors store electricity, and a magnetic field is how inductors store electricity, and that's a test question. So I is inductor, or L, actually, they're L in the schematic. Then there's relays, diodes. We talked a little bit about diodes last week. So for example, LED stands for light emitting diode, and the function of a diode is for one-way flow of electricity. So electricity goes out and it can't come back in. So think of like a revolving door that only goes one direction. Once it goes through, it can't come back. So that's the function of a diode. And then there's transistors, and if I remember right, it's Q. It tells you right there in the diagram, it says Q and then a number. So the letter Q on the schematic is a transistor. Switches is an S. B is for battery, or BT, and then a number like battery number 1, 2, 3, 4 if they have multiple batteries. Ground, the most common one is the earth ground, which looks like a line with an arrow that gets increasingly smaller as it points down. Then there's voltage wiring. Fuse is an F, which is, it looks kind of like a cylinder shape with two little stripes on either side. And then the other one is antenna, which is kind of looks like three forks pointing up, or like three little fingers pointing up. So those are some of the basic schematics. So now going back to 3-8 and 3-9, some of the measurements that you need to know. So capacitance is measured in what's called farads. Inductance or magnetism is measured in henries. And volts, amps. Volts is like pressure, electrical pressure or power. It's also known as EMF, electromagnetic force. I is current flow or amps. The letter A, you'll see that a lot on any kind of electronic. It'll say 3A for 3 amps and a number of volts. So for example, a little transformer or adapter that you would go from say 120 volts to 12 volts. If you have a 12 volt based appliance that you're trying to use at home, you'll have a little transformer or adapter, and it will say on there 3V or 12V or whatever, which is the number of volts that transformer will put out, and it usually have a number of amps. So for example, if you're charging your phone and you have a slow charger, it might be 1.1 amps in a USB connection, and if you have a fast charger, it might be like 3 amps. So it's more current, so you can charge faster, and it takes less time to charge your cell phone battery. Then they have some pictures on 3.8 of capacitors. There's disc capacitors, and there's ones that look like kind of like little batteries sticking out. And then there's resistors, which are just like these cylinders. And so 3-9, we're going to go into inductors. I mentioned that last week a little bit, but they have what are called air. They're air inductors that just have just a spiral coil that's just air in the middle. If you want one that's stronger, they will put an iron core, and you wrap the wire around the iron core, and that makes the field stronger. And then down below in figure 310, you have potentiometer, adjustable or variable. And that's like, for example, a volume control on like a radio or a TV or something like that. TVs now, they're all digital, right? You just push up and down or remote control. But back in the olden days, they used to have stereos and radios and things with mechanical knobs. Well, they would use these variable resistors or potentiometers to increase or decrease the resistance. Less resistance, more current, louder volume on a speaker. More resistance, softer volume, less current. So, all right, so I'm going to go on to 3-10 and cover some of these topics. So impedance is kind of resisting the flow of electricity. That's making the electricity that can go through is less. And so what it does is it converts electricity into heat. Sometimes that comes out as heat. And so I'm going to go over some of the questions on 310. At the top, it has T5, which is test bank area 5. CO5 says, what is a unit of impedance? The unit of impedance is ohms. It's a measurement of resistance. And so the next question is, what is impedance? Impedance is just opposition or resistance to current, opposition to current. Okay, so the other thing, I mentioned this last time, but an LC circuit or inductor capacitor circuit is, think of if you had like 2 glasses of water and they were both full. Well, we'll say one was full and one was empty. So you take the full one and you pour it into the empty one. And then you take the empty one and the full one that was empty, and then you pour it back, and you go back and forth. Okay, so that's kind of what the electricity does in an inductor on one side and a capacitor on one side. It stores it electrically in the capacitor, it discharges it, puts it through the inductor, and then the inductor becomes charged, and then the inductor will then discharge and go back to the capacitor. And if you put a diode in between it, it will light up. So you're basically, anytime the electricity goes one direction, it lights up, and the other direction, it doesn't. It will turn dark, and that's how you get a flashing LED. So they use flashing LEDs with an LC circuit or inductor capacitor combined. You can combine those in various amounts to create resonance, and you create a frequency up. So like when the electricity is going back and forth, it's creating a wave up and down. And depending on how fast or how slow it's going, you can create different frequencies. So the question here in the middle on resonance, T6B08. Which of the following is combined with an inductor to make a resonant circuit? Well, it's a capacitor. The capacitor stores electricity while the inductor discharges, and vice versa. Let's see. Okay. The next one, diodes, transistors, and integrated circuits. So a diode, as I mentioned, is to have electricity go one direction. So the question is, what component allows the current to flow in one direction? The answer, diode. So that's pretty easy. Which of these components can be used as an electronic switch? Okay, so transistor. So if you think about like when transistors were first created, invented, discovered, whatever the word is, transistor radio was like a big thing when they figured out how they could do that. Well, a transistor is just simply an electrical switch. So you have what's called a base, a collector, and let's see if I can remember the other name. Base, collector, and emitter. That's what it is. So on 315, I have a list of some of those different types of transistors. Without going too much into the physics of it, there's an anode and a cathode. Actually, that part you need to know. An anode and a cathode is like a positive and a negative of a battery terminal. So you have one direction that the electricity goes from to. It goes to this, to the other one. So one is a cathode and one is an anode. And the transistor, based on the gate, can open and close. It can go from one to the other. It can let electricity open or close. And you put millions of transistors on a chip, and that's how you get a computer. So just basically a bunch of transistors on a silicon wafer. So a transistor is used to is an electronic switch, and that's the question T6B03 on 310. So all right. Which of the following components can consist of three regions of semiconductor material? Okay, so semiconductor, like silicon, they have what are called PNP transistors and NPN transistors. I can't remember what it stands for now, but they're just layers of physical material, and it depends on, let's see here, is N-type or P-type. So it's on 3-11, about in the middle. They call it doping, so it's stuff they put on top of the silicon, like a layer. So it depends on if they put an N type of layer or a P type of layer, and depending on the order they put it in is the type of transistor that it can make. So a PN transistor is one that has P material, then N material, and then so it's just the order, NPN, PNP, whatever. So that's all you need to know about that, really. There's different types of transistors, and T6B05 on 310, which is towards the middle, about halfway through those questions. It says, what type of transistor has a gate, a drain, and a source? So the answer to that is a field-emitting transistor. It's FET. So it's a FET transistor. And I don't know what it means exactly, the difference. You can see the diagram for it on 315. They have a junction FET about here. So these are the 6 different types of transistors that they show. There's a PNP, an NPN, P channel, N channel. I don't know all of them, but you just have to know FET is field emitting transistor. Boba Fett, yeah. Boba Fett, think Star Wars, right? FET is field emitting transistor. Anyway, so there are different types of transistors. That's all you have to know. Then the next question, T6B06, which says, how is the cathode lead of a semiconductor diode often marked on a package? So there's a cathode and anode, which is kind of like a positive and a negative. And how are they marked? It's usually marked with a little stripe. So they have little stripes on them so you know which end of it is which. The next question says, what causes a light-emitting diode to emit light? Well, it's a voltage drop, or voltage is, current passing through. The abbreviation FET is the field-emitting transistor. That's the next question. What are the names of the electrodes of a diode? That's the anode and the cathode. It's one direction and the other direction. So it's just sides of a transistor, or sides of a diode. Which of the following can provide power gain? Okay, so there's an RF powered I don't know if it's transmitter or transformer. RF power. I put trans. I can't remember what it was now. T6B10. What is the term that describes the device's ability to amplify a signal? Okay, so the answer to that is gain. So gain is like if you have a antenna that has a direction to it. The gain is the direction that the wave is magnified or amplified. So there's a type of antenna called a Yagi antenna, which is back in the, let's say, 70s, 80s, the old antennas on VHF and UHF TV antennas. They're like, there's a picture of it on the next chapter, but a Yagi antenna has like a long wire and then a shorter and a shorter and a shorter wire. So it ends up creating like an arrow effect. And so that arrow, where it points, is the direction that the antenna is going to transmit or receive. So the gain is the direction of the signal strength. Gain can also mean you're amplifying the signal. So in terms of amplifying a signal, it's called gain, and it's measured in dB or decibels. And it is a logarithmic scale, similar to, say, the Richter scale. So you're familiar with earthquakes, like a 1.0 and a 2.0. A 2.0 is 10 times more powerful than a 1.0. And a 3.0 earthquake is 100 times more powerful than a 1.0. So you just keep times 10 after each number. So 1, 2, 3, 4. So 4 is 10 to the 4th, so it's 1,000 times more powerful than a 1.0, so a 4.0 earthquake. Well, it's the same thing with sound as well as electromagnetic waves. So a gain in a signal of 1 dB to 2 dB, 2 dB signal is 10 times as powerful as a 1 dB signal. So if you have a 3 dB gain, that's like a 100x factor. So we'll get into that in chapter 4 a little bit when we go into antennas. But all right, what else? Which of the following devices or circuits changes an alternating current into direct current? A varying direct current. That's the answer to that is a rectifier. And I don't really know too much about rectifiers, other than that's the answer to the question. It changes from alternating to DC, which is kind of like what a transformer does. The next question, and I'm on 3-11 here at the top. It says, which of the following is commonly used as a visual indicator? That's an LED light. An LED light emitting diode is commonly used as like, hey, power's on. You got a little red light, green light, whatever color it might be, amber, white. So that's usually what they use. They use LEDs for that to indicate something is on or something like that. And then the next question, what is the name of a device that combines several semiconductors and other components into one package? So that's called an integrated circuit or IC chip. On a schematic, it will be labeled IC. Integrated meaning you have a whole bunch of things connected, interconnected together. So let's just take the older example of a computer PC sound card. A sound card is an integrated chip. Well, it's got several integrated chips on it. It's more like a card, I guess, or a board. If you put several components together, it would be a board, but one chip might have lots of different things within the circuit. So it's an integrated circuit. Semiconductors, we've talked about that. Is used for like transistors. It can conduct electricity depending on how much electricity is flowing through it. If you increase it, it will conduct the electricity. If you decrease the voltage, it will decrease it and turn it off. And so that's how a circuit goes from on to off. It's just the amount of current that you put through it. Let's see. Oh yeah, so heavy-duty diodes that can handle large voltages and currents are called rectifiers. So that's 3-12 at the top. And then anode and cathode, we talked about that. Transistors in the middle of the N and P layers can have 3 layers. So I've talked about those different layers, NPN or PNP, depending on the order you put them in. Using a small signal to control or amplify signals is called gain. So your antenna has a gain. If it's small antenna, if it's a large antenna, it will have a high gain because it can pick up more of the signal. Think of it as like a satellite dish. It's collecting radio waves. You can do the same thing with the sun or with sound, and you can collect it and focus it on one point. So you're collecting, oh, so like an antenna, a long antenna will collect more of the wave than a shorter antenna is going to collect like a half of it or a fourth of it, depending on the type of antenna it is. If it's like a half wavelength antenna or a full length antenna, a full wavelength. So if you're on a 6 meter band, a full wavelength antenna would be 6 meters long, which is about 18 feet. So if you want 6 meter full wavelength, you're going to get an 18 feet antenna, which is pretty big. So if you cut that in half and do a half wavelength antenna, say 9 feet, then you might want to get an amplifier to amplify the signal. So you're going to pick up just a smaller amount of the electrical signal passing across the antenna, and then you're going to amplify it with an amplifier. And so that's one way to compensate for having to put up a big antenna, is like have an amplifier or something like that. You can only amplify a signal so much though. So let's see. And there's a couple other types of transistors. They mentioned bipolar junction transistors. You can study that in the schematic there on the other page of all the schematics. Integrated chip, I've talked about that. Oh, okay, this one's pretty easy. What type of electrical component is used to protect other components from overload? So that is like you have in your house a circuit breaker or a fuse. So it's fuse is the answer. And there's in the schematic there's examples of what a fuse looks like on the diagram. What is the purpose of a fuse in there is to prevent overload. So if you put too much current through a circuit, it can burn out whatever component it is, whether it's a wire or an LED or whatever. And so you put a fuse in there so that it will burn out the fuse before it burns out the rest of your components. This one is pretty, it's almost like self-explanatory, but why should a 5 amp fuse never be replaced with a 20 amp fuse? So if you have something like, let's say I have this radio and I might have like a 5 amp fuse in it. Well, if you increase it to 20 amps, that means you're going to have 20 amps of current going through it, which is probably easily going to fry the smaller electronics in something like this. So you never want to replace a small amp fuse with a greater amp fuse, because then you're going to put more current through it, which you can damage your equipment. You could put a smaller one, like a 5 amp fuse. You might put a 4 amp fuse and it might still work. But it's always better to go less in the amps when you're talking about a fuse or a circuit breaker than larger, because the larger one you might risk damaging your equipment. And also it can cause a fire. Okay, so in your home, that's why you have circuit breakers. So let's say you plug in electrical heater in your home and you plug it into the 120 volt and you turn it on and you walk away. Well, after a while, that cord or that heater can heat and gets really hot. And the wires in your house actually will produce electric heat as well. It's going to produce heat energy, and electrical energy is going to produce a lot of heat. And in a bad case, it can heat up and cause a fire or spark. And so if it heats up too much and you have too much current flowing there, that's what the circuit breaker is designed to do. It's designed to cut off the current so that it doesn't heat up such that it can create a fire. So that's one of the purposes of the fuse. And they have some examples on 3.12 of a circuit breaker that's like you might find in your house. And then you have different types. You have like the round cylinder types that you used to find in older cars. Now they look more like these square looking things or rectangle looking things. And they'll have like a number on top. So in this figure, it has the number 10. That's a 10 amp fuse. The 10 amp is how much current can go through that fuse before it will burn out. These ones are just one-time use. Like once you burn it out, you got to replace the fuse. Whereas the circuit breakers, you can like trip them and then reset them and then trip them and reset them. And they have multiple use. It can be tripped multiple times. Then there's what's called the GFCI, ground fault circuit interrupter. I don't know if there's any questions on that, but basically that is for your home. Most building code says if you have an electrical outlet by any source of water, like a sink or a bathtub or a kitchen, then you're required to put a GFCI circuit in. That's so that if, let's say you're drying your hair and you accidentally drop it in the sink and your sink has water, then it can create a spark. Or if you're in the bathtub, for example, you can get shocked. So the idea is it would trip the circuit and shut off the electricity faster than the electricity can reach your heart and stop. So it has to stop pretty quick. There's actually a millisecond time that it has to stop within in order for it to be effective. All right, so the next one, gatekeepers, 313. That one is, their acronyms is SPDT, single pole double throw. So there's a couple of examples of different types of switches on 315. There's SPST and SPDT. SP is single pole, ST is single throw, and then DT is double throw. So you can have a single pole single throw switch and a single pole double throw switch. So example is right here in that schematic there. So it's kind of like the light switch, it either goes on or off, but in a single pole double throw, you're either turning one circuit on or the other circuit on, depending on which direction the switch is facing. And then you can take that times 2 and have a double pole single throw and a double pole double throw. So those are the different types of switches, and they might have acronyms and ask you what this means. So T6A03 on 313 at the bottom, it says, what is the function of an SPDT switch? So it's single pole double throw, and it's designed, the function is to make current go through path A or path B. Whereas a single pole single throw is to either turn on or off the electricity, like a light switch. An SPDT switch is to either route it between path A and path B, but the electricity still stays on. What is a relay? A relay is a switch by an electromagnet. So an electromagnet, I remember in, I think it was grade school actually, when they introduced us to the concept of an electromagnet. So they said, everyone tomorrow bring in a 6-volt lantern battery. We don't use those anymore, but back in those days they had a little 6-volt battery. And everyone brought in a 6-volt battery and bring in a nail and some wire. And that's all it was. And you just take a positive and a negative, and then you take a wire and you wrap it around a nail, and then you hook it up, and as soon as you connect them, the electricity is flowing through that nail, which is iron, and electricity flowing around iron creates a magnetic field. It induces a current, it induces an electromagnetic current, and so that creates an electromagnet. So when you hook the positive and negative of the 6-volt battery, and then you take the magnet, the nail, which then is a magnet, and you touch another piece of metal, it'll pick it up. And if you disconnect it from the battery, the switch there's no magnetism in it, and then it would just drop. So whatever you had, like let's say you're picking up a little pin, and it's magnetized and turns on, it's holding the pin, and when you disconnect it, it'll just drop. So it turns on and off the electrical magnetic field. So they do the same thing in a relay, except instead of the pin and the nail might be a positive side of the current, and the pin might be the negative side. And if you turn on the switch, it connects them and contacts them, and if you turn off, it'll pop it open. And they put a spring in between it so that it's designed to stay open or stay closed, depending on which direction it is. It might be designed to stay open. When you put on the current, they attract and touch each other for magnetism, and when you turn off the current, it disconnects. And that's how a relay works. So a function of a relay is just to turn on and off a circuit through an electromagnet. So that's T6DO2 at the bottom of 313. So usually you have a switch to turn on and off the magnet. So the switch is operated manually, while a relay is a switch controlled by an electromagnet. Okay, so schematic, here's the question. This is kind of like the answer. What is a schematic? What is the name of an electrical wiring diagram that uses standard component signals? The answer is schematic. So on 315, you have examples of schematics that I've been talking about. And they have figures. They'll give you like a sample schematic on figures 315 and 316. 316, they'll give you something like this on the test. And this one has like 3 different groups of components, and they'll number them and put a letter, and they say, what is this? C1, what is C1? What is R1? C1 is a capacitor, R1 is a resistor. So they'll ask you, what is it? What's the function? So example, you have diagram A, B, and C, or diagram T1, T2, and T3. So let's take T1 for example. And T1 says, on the bottom, you have these little fork-looking things sticking out. Those are grounds. And on the left, you have a battery. It says BAT, or BT1. That's battery number 1. And it has a positive and negative, so you know which one's the positive, which one's the negative. There's a couple different grounding symbols. One is the little fork-looking thing. The other's like an arrow. The fork-looking thing means it's grounded within the circuit. And if it's got an arrow, then it's grounded towards the actual earth, so it has to connect to the earth. So like in your home, there's usually a grounding rod. It's usually by your circuit breaker, your main breaker, and sometimes they'll put it into the concrete or something like that. And the idea is if something shorts out, it'll go right into the ground instead of into you and shock you. So a grounding rod is needed for also lightning. It's kind of like if lightning were to hit something in your house, it would go to the ground instead of catching fire or going somewhere else. So ground, they have a little zigzag looking thing. It says R, that's a resistor. And this little circle thing with an arrow or diode in the middle, that's a Q, which is a transistor. DS is for LED. I don't know why they use DS, but they do. And then you have like example number 3, you have this 4, which is the antenna, kind of like 3 little prongs pointing up. C is capacitor, so just kind of know some of those schematics. All right, so let's go into 317, oscillators and amplifiers. Okay, so this is a simple, figure 317 is a simple diagram of a CW transmitter. So CW stands for carrier wave, also known as Morse code. So what Morse code does is it's kind of like, a dot or a dash. It's the length of the tone. Like that. So that's long, and then short would be. So for example, SOS is three dots. It's like and then O is 3 longs. And then another 3 for S. So SOS is so all you do is 3 longs, 3 shorts, 3 longs. And you don't need to know that for the test, but it's good to know in case there's an emergency how you would signal for SOS. But the way a simple transmitter works is for CW, you have an oscillator, which is the source of the sound, whether it's a high or a low pitch like do, and then the driver, and you have an amplifier and the telegraph key. So the key either makes it turn on or off. So anytime you touch, it's creating a circuit, and it's completing the circuit and creating the sound and sending the frequency, depending on what kind of frequency you're sending out, if it's a high or low sound, through the antenna. So that's a simple CW transmitter that uses an oscillator, which is something that creates waves electrically on a certain frequency range. Okay, so the bottom of 317, the question is, which of the following describes combining speech with an RF carrier signal? So RF stands for radio frequency. When you convert a radio frequency into speech, that's called modulation. So that's where you get the term modem. Back in the old days, modem was modulate, demodulate. So it was mo and dem, modulate or demodulate. And so that's the function of a modem or modulator, is to convert from speech into electrical energy or from electrical back to speech. That's how radio waves work. It transmits it on a frequency and then it converts it back into sound that we can hear. So modulation circuit. And what is the following, and the last one on 318, which of the following is used to convert a signal from one frequency to another? That's called a mixer. So it can mix from one frequency to another. They're used in both transmitting and in receiving. And the circuit should not be confused with an audio mixer that combines 2 different audio signals. They just had that little note. Okay, I'm going to pause my recording, and then we're going to go into chapter 4, second half.